Okay, in the previous video, what we have seen that different types of vectors. የተለያዩ ቬክተሮችን ለማየት ሞክረናል. So today we will see addition and subtractions of vectors. ስለዚህ በዛሬው ቪዲዮአችን ደግሞ እንዴት ቬክተሮችን መደመርና መቀነስ እንዳለብን አብረን እናያለን. So if you are ready, let's begin right now. To determine the resultant of two and more than two vectors, we commonly use two methods. The first one is graphical method of vector addition, and the second one is algebraic or analytical method of vector addition. So let's see what is the word resultant የሚለውን መጀመሪያ ማየት ያስፈልጋል. So when you say resultant, it is the summation of two and more than two vectors. የሁለት ቬክተሮች ድምር ውጤት resultant እንለዋለን. Okay, graphical method of vector addition is one of the methods to combine vectors graphically. ስለዚህ እዚህኛው ሜተድ ላይ graphically ወይንም በዲያግራም መልክ እንዴት ቬክተሮችን ኮምባይን ማድረግ እንደምንችል የምናይበት ይሆናል. The second one is algebraic or analytical method of vector addition. In this case, how to combine vectors mathematically. Mathematically ቬክተሮችን የተለያዩ ሜተዶችን በመጠቀም እንዴት መደመር እንደምንችል የምናይበት ይሆናል. So now let's see a graphical method of vector addition. Graphical method of vector addition. So under this method, we have different techniques to combine two and more than two vectors. ሁለትና ከዛ በላይ የሆኑ ቬክተሮችን ለመደመር የሚያስችሉን ሶስት አይነት ሜተዶች አሉ ነው. So let's see one by one. The first one is triangle law of vector addition. To find the resultant of two vectors by using triangle law of vector addition, we have to connect or place the two vectors head to tail. ሁለቱም ቬክተሮች head to tail በማገናኘት ሪዛልታንታቸውን ማግኘት እንችላለን ማለት ነው. So we have to connect the two vectors head to tail. Let's say this is vector A and this one is what? Vector B. ስለዚህ እዚህ ጋር እንደምታዩት ሁለቱ ቬክተሮች head to tail ነው ኮኔክት ያደረግናቸው. The head of the first vector is connected to that of the tail of the second vector of vector B. የቬክተር B tail እና የቬክተር A head connect ይሆናሉ. So the resultant or the summation of the two vector is drawn from the tail of the first to the head of the last or the second vector, which is A plus B. ስለዚህ የሁለቱ ቬክተሮቹ ድምር ከመጀመሪያው ቬክተር ቴል ወይንም መነሻ እስከ ሁለተኛው ቬክተር መድረሻ የሚሳለው ይሆናል. So this is all about how to combine vectors by using triangle law of vector addition. ስለዚህ አንዱ ሊሚቴሽኑ ምንድነው? triangle law of vector addition combine የሚያደርገው only two vectors. It only adds two vectors. ስለዚህ vector A plus vector B gives the arrow drawn from the tail of the first to the head of the last ብለን በዚህ መልኩ ድሮ ማድረግ እንችላለን ማለት ነው. ድሮ ማድረግ እንችላለን. So the next one is if it is all about the resultant or the summation of the two vector are, how to find its magnitude and direction. Already አቅጣጫውንና ማግኒቲዩዱን እንዴት ማግኘት አለብን የሚለውን ደግሞ ለማወቅ ከፈለጋችሁ simply you can use sine law. Sine law መጠቀም እንችላለን. So if it is r, let's say this is theta and this one is angle beta, and this, let's say this is alpha ብንለው, you know, this is vector A, this one is vector B, and this one is what? The resultant of the two vector, right? ስለዚህ የሁለቱ ቬክተሮች ድምር ከሆነ, so simply we can use sine law to determine the magnitude and the directions of what? The two vectors. Let's see sine law. Sine law. So vector A over its opposite angle, vector A over sine alpha is equals to vector B over sine theta, vector B over sine what? Vector B over sine theta, which is the same as the resultant vector R over what? Sine beta. Sine beta. So this is all about sine law. So let's, based on this formula or general formula, you can determine the vectors A and B and also the resultant one and the angles. So this is all about triangle law of vector addition. Triangle law of vector addition. Let's proceed to the second one, which is parallelogram law of vector addition. ስለዚህ እዚህ ጋር ምን ብለን ነበረ? In the case of triangle law of vector addition, we have to connect the two vectors head to tail, right? Okay. Under parallelogram law of vector addition, we have to connect the two vectors or combine the two vectors tail to tail, and the arrow drawn from the tail of the two vector to the opposite corner of the parallelogram represents the resultant of the two vectors. Let me draw the free body diagram. Let's say this is vector A. This is vector A, and this one is vector what? Vector B. Vector B. Let's say this is theta angle between A and B. So let me draw an imaginary line which is parallel to B, start from this point. Let B parallel የሆነ imaginary line በዚህ መልኩ draw ታደርጋላችሁ, and then you have to draw an imaginary line which is parallel to A. So the arrow drawn from the tail of the two vector to the opposite corner of the parallelogram represents the summation of the two vectors A and B. ስለዚህ this is resultant R, which is the same as A plus B ብለን በቀላሉ ፍሪ ቦዲ ዲያግራሙን በዚህ መልክ መስራት እንችላለን ማለት ነው። So what we have to keep in mind here is that in the case of triangle law of vector addition, we have to place the two vectors what? Head to tail በማገናኘት the arrow drawn from the tail of the first to the head of the last represents the resultant one. But in the case of parallelogram law of vector addition, we have to combine, or we have to connect the two vectors with the same origin, and the diagonal which is passing through their origin describes the summation of the two vectors. So the next one is how to find their magnitude and direction in the case of parallelogram law. አሁን triangle law of vector addition ላይ just simply ምን መጠቀም እንችላለን ብለናል? Sign law. Likewise, to determine the magnitude and the directions of the two vectors in the case of parallelogram law, we can use cosine law, which is the same as resultant R square is equals to vector A the whole square plus vector B the whole square plus or minus 2 times of AB cos theta. So this is all about cosine law እንለዋለን ማለት ነው። So that is the summation of the two vector R. ስለዚህ R square is equals to A square plus B square plus or minus 2 times of AB cos theta, where theta is what? Theta is equals to angle between the two vectors A and B. በቬክተር A እና በቬክተር B መካከል ያለው አንግል ቴታ ይሆንልናል ማለት ነው። ስለዚህ በቀላሉ ቴታን ማግኘት ከቻልን ዳይሬክሽን አገኘን ማለት ነው፣ ወይም በቀላሉ አርን አገኘን ማለት የሁለቱ ቬክተሮችን ድምር ውጤት ወይም ሪዛልታንት አገኘን ማለት ነው። So this is the way how to find the summation of two vectors by using parallelogram law of vector addition. The same is true here. እዚህኛው ላይ ሁለት ቬክተሮችን ብቻ ነበር መደመር የሚችለው ብለናል። Likewise, parallelogram law also combine only two vectors. ሁለት ቬክተሮችን ብቻ ነው ለመደመር የሚያስችለን። Let's proceed to the third one, which is polygon law or scale diagram. Okay, in the case of polygon law of vector addition or scale diagram, we have to connect all the vectors head to tail in any order. በፈለጋችሁት መደርደር ትችላላችሁ by ensuring the directions of all the vector is correct. And then the arrow drawn from the tail of the first vector to the head of the last vector represents the summation of all the vectors. In addition to this, if you end where you started, all the vector is cancel out with each other and there is no resultant vector. ስለዚህ ቬክተሮችን ሄድ ቱ ቴል ኮኔክት አድርገን በመጀመሪያው ቬክተር መነሻና በመጨረሻው ቬክተር መድረሻ መካከል ምንም አይነት ጋፕ ከሌለ ሁሉም ቬክተሮች ካንስል ተደራርገዋል ማለት ነው። which means that there is no resultant vector which is acting in a given system or in a given free body diagram ብለን ማየት እንችላለን። So let's see the free body diagram. Okay, if we have a numbers of vectors, let's say this is vector A. And if we have another vector, let's say this is vector B here. And if we have another vector, let's say vector C, and here vector D. እንደዚህ አይነት ቬክተሮች ቢኖረን አሁን እዚህ ጋር ማየት ያለባችሁ ትራያንግል ሎ ቬክተር አዲሽን እና ፓራሌሎግራም ሎ ቬክተር አዲሽን ላይ ሁለት ቬክተሮችን ብቻ ነበር ኮምባይን ማድረግ የምንችለው። In the case of scale diagram or polygon law vector addition, we can combine two and more than two vectors. ሁለትና ከዛ በላይ አምስትም ሊሆን ይችላል፣ አስርም ሊሆን ይችላል, whatever it is, we can combine all the vectors by using polygon law of vector addition. ስለዚህ ቅድም እንዳልኳችሁ we have to draw all the vectors by ensuring the directions of the vector are correct. የቬክተሮችን አቅጣጫ በደንብ መሳልና ሄድ ቱ ቴል ማገናኘት in any order ነው ያልነው። ያ ማለት ኤ እና ቢ ቦታቸውን ቢቀያይሩ አጠቃላይ መጨረሻ ላይ የሚመጣው ሪዛልታንት ወይም ድምር ውጤት ላይ ምንም አይነት ኢፌክት የለውም ማለት ነው። ኢፌክት የለውም። ሶ the arrow drawn already አሁን ቬክተሮች ምን አድርገናል? connect what all the vector is connected what head to tail አይደል እንዴ? the head of the first to the tail of the second, the head of the first to the head of the second. ስለዚህ head to tail connect አድርገናል። the arrow drawn ከዚህ በኋላ ምንድን ነው ያለው? the arrow drawn from what? the tail of the first to the head of the last vector represents the resultant one. So this is the arrow which is drawn from the tail of vector A to the head of the last vector which is vector D. So this is resultant, which means that vector A plus vector B plus vector C plus ምን vector D የአራቱ ቬክተሮች ድምር ይችኛዋ ናት ማለት ነው። ይችኛዋ ናት ማለት ነው። ስለዚህ ፎር ኢንስታንስ ይችኛዋ ቬክተር ፊቷን ወደዚህ አዙራ ቢሆን ኖሮ ያ ማለት እዚህ ሌላ ቬክተር ከቬክተር ዲ ተነስቶ እዚህ ጋር ቢሆን ኖሮ all the vectors what cancel out with each other and there is no resultant vector. ስለዚህ ምንም አይነት ሪዛልታንት አይኖረንም ማለት ነው። so this is all about how to combine vectors by using polygon law vector addition or scale diagram. Now let me elaborate our discussion by using this examples. ይህን ኤግዛምፕል በመጠቀም የተለያዩ ፊቸሮችን እናያለን ማለት ነው። okay, let's see the free body diagram. Here vector C and vector B is what? Connected head to tail, and vector A is drawn from the tail of vector C to the head of what? The second vector, right? ስለዚህ አሁን ቬክተር C እና ቬክተር B ሄድ ቱ ቴል ተገናኝተው ኤ ደግሞ ከመጀመሪያው ቬክተር መነሻ እስከ ሁለተኛው ቬክተር መድረሻ ተስሏል። which means that vector A is equals to what? Vector A is equals to vector C plus vector B, which is vector B plus vector C. የቢ እና የሲ ድምር ውጤት ኤ ይሰጠናል ማለት ነው። እዚህኛው ላይ ስንመጣ ደግሞ which one is connected head to tail? head to tail connect የሆኑት እነማን ናቸው? vector B and what? vector A. the head of vector B is connected to the tail of vector A, and the arrow drawn or vector C is drawn from the tail of vector B to the head of vector A. ስለዚህ ምንድነው ሊሆን የሚችለው? የቬክተር A እና የቬክተር B ድምር ውጤት ማንን ይሰጠናል? ሲን ይሰጠናል ማለት ነው። ስለዚህ vector C is equals to vector A plus vector B. የቬክተር A እና የቬክተር B ድምር ሲን ይሰጠናል። እዚህ ጋር ስንመጣ ደግሞ already vector A and vector B is connected head to tail. ሁለቱ ቬክተሮች head to tail ተገናኝተዋል. but there is no vector which is drawn from the tail of vector A to what? the head of vector B. እዚህ ጋር እንደምታዩት በተቃራኒው ቬክተር C ከቬክተር B መድረሻ እስከ ቬክተር A መነሻ ነው የተሳለው። ቬክተር A መነሻ ነው። so in this case all the vector is what? connected head to tail, and there is no what? there is no gap between them. so ቅድምም ብለናል if you end where you started all the vector is what? cancel out with each other and there is no resultant vector. ምንም አይነት ሪዛልታንት ቬክተር የለም ማለት ነው። ምንም አይነት ሪዛልታንት ቬክተር የለም። ስለዚህ ቬክተር A plus vector B, vector B plus vector C gives 0. There is no resultant vector. That's why all the vector is connected head to tail and there is no gap in between. ምንም አይነት ጋፕ ስለሌለ ሪዛልታንት ቬክተራችን ዜሮ ነው የሚሆነው ማለት ነው። ስለዚህ ዛሬ ግራፊካሊ እንዴት ቬክተሮችን ኮምባይን ማድረግ እንዳለብን አይተናል። ኦኬ ግራፊካል ሜተድ ኦፍ ቬክተር አዲሽን ላይ ዲቴይል ቪዲዮ እንዲሰራበት ከፈለጋችሁ ኮሜንት ላይ ጻፉልኝ። አመሰግናለሁ።